What's up everyone, it's Ahmad, and welcome back to the channel. Today, we're diving into the top 10 most powerful electrical devices in the world. These are the machines that push the boundaries of technology and innovation, from the supercomputers solving complex equations to the rockets propelling us into space. We're about to explore the engineering marvels that define our modern world. We'll break down how these devices work, why they're so powerful, and the impact they have on our lives. This isn't just about wattage and voltage, it's about understanding the sheer scale and ingenuity behind these incredible feats of engineering. So, buckle up, hit that subscribe button if you haven't already, and let's get right into it. First up, we have the heavyweights of the computing world, supercomputers. These machines are in a league of their own, capable of performing quadrillions of calculations per second. We're talking about processing power that's millions of times faster than your average laptop. But what makes them so powerful? It all comes down to the sheer number of processors and specialized hardware they pack. Imagine thousands of high-end gaming PCs all linked together, working in perfect harmony. That's the kind of power we're talking about. Supercomputers are used in a wide range of fields, from scientific research and weather forecasting to financial modeling and even artificial intelligence. They're the go-to tools for scientists and engineers who need to crunch massive amounts of data and solve complex problems that are beyond the reach of conventional computers. Take for example the Summit supercomputer, one of the fastest in the world. It's being used to simulate the behavior of the COVID-19 virus, helping researchers understand how it spreads and develop potential treatments. That's the kind of real-world impact these machines can have. But it's not just about raw power. Supercomputers are also incredibly energy-intensive. These beasts can draw as much power as a small town, requiring sophisticated cooling systems to prevent them from overheating. So, next time you boot up your laptop, spare a thought for these computing giants pushing the boundaries of what's possible in the digital realm. Next, we journey into the world of particle physics and the Large Hadron Collider, or LHC. This massive machine, buried deep beneath the French-Swiss border, is the world's largest and most powerful particle accelerator. Now you might be wondering, what exactly does a particle accelerator do? Well, it smashes protons, those tiny particles found in the nucleus of an atom, together at nearly the speed of light. These collisions release enormous amounts of energy, allowing physicists to study the fundamental building blocks of the universe. The LHC is a marvel of engineering, spanning a 27-kilometer ring and requiring an incredible amount of power to operate. We're talking about enough energy to power a small city, all focused on creating these microscopic collisions. But why go through all this effort? The LHC is helping us answer some of the most fundamental questions about the universe. What is the origin of mass? What is dark matter? Are there extra dimensions? These are the mysteries that the LHC is helping to unravel. One of the most groundbreaking discoveries made at the LHC was the Higgs boson, a fundamental particle that gives other particles their mass. This discovery was a major triumph for physics, confirming the existence of a particle that had been theorized for decades. The LHC is a testament to human curiosity and our quest to understand the world around us, even at its smallest scales. Let's shift gears now and talk about something a little closer to home: electric locomotives. These powerful machines are the backbone of many modern rail networks, hauling freight and passengers across continents with incredible efficiency. While they might not have the sheer size of a particle accelerator, don't underestimate the power these locomotives pack. We're talking about thousands of horsepower generated by electric motors, allowing them to pull massive loads and reach speeds of over 200 miles per hour. What makes electric locomotives so remarkable is their efficiency. Unlike diesel-powered trains which rely on internal combustion engines, electric locomotives draw power directly from the grid. This means fewer emissions, less noise pollution, and lower operating costs in the long run. And when it comes to hauling heavy cargo, electric locomotives are in a league of their own. They can effortlessly pull freight trains stretching for miles, transporting everything from raw materials to finished products. But it's not just about brute strength. Modern electric locomotives are also equipped with advanced control systems that optimize their performance, ensuring smooth acceleration, regenerative braking, and minimal energy waste. So, next time you see a train speeding by, remember the silent power of electric locomotives, driving us towards a more sustainable future. Now let's talk about harnessing the power of light, specifically, industrial laser cutters. These machines use high-powered lasers to cut through materials with incredible precision, making them essential tools in manufacturing, fabrication, and even surgery. We're not talking about your average laser pointer here. Industrial lasers can generate beams with kilowatts of power, enough to slice through steel, titanium, and other tough materials like butter. But how does it work? The laser beam is focused onto a tiny spot, generating intense heat that melts or vaporizes the material. And because the laser beam is so precisely controlled, it can create incredibly intricate cuts and engravings. Industrial laser cutters are used in a wide range of industries. They cut the metal parts for your car, engrave the logos on your electronics, and even shape the intricate designs in jewelry. And in the medical field, laser cutters are used for everything from eye surgery to tumor removal, thanks to their precision and ability to cauterize blood vessels as they cut. The next time you marvel at a complex piece of machinery or a delicate piece of jewelry, remember the power of lasers shaping our world with pinpoint accuracy. From the microscopic precision of lasers, we now blast off to the realm of space exploration with the SpaceX Falcon Heavy. This behemoth of a rocket is the most powerful operational launch vehicle in the world, capable of lifting over 140,000 pounds into orbit. The Falcon Heavy isn't just about raw power, it's a marvel of engineering. With 27 Merlin engines firing in unison, this rocket generates over 5 million pounds of thrust at liftoff. That's like 18 Boeing 747s taking off simultaneously. But what really sets the Falcon Heavy apart is its reusability. After delivering its payload into space, the rocket's boosters and central core can return to Earth and land vertically, ready to fly again. This reusability is a game changer, making space travel more affordable and accessible. The Falcon Heavy has already achieved some incredible feats, including launching Elon Musk's Tesla Roadster into space and deploying satellites for various government and commercial customers. But this is just the beginning. The Falcon Heavy paves the way for even more ambitious missions, like sending humans to Mars and beyond. It's a testament to human ingenuity and our relentless pursuit of pushing the boundaries of what's possible. Let's shift our focus now to the giants of energy production nuclear power plants. These facilities harness the power of nuclear fission, splitting atoms to generate massive amounts of electricity. Nuclear power plants might seem complex, but the basic principle is relatively straightforward. Inside the reactor core, uranium atoms are bombarded with neutrons, causing them to split and release energy in the form of heat. This heat is used to generate steam, which drives turbines that produce electricity. What makes nuclear power so remarkable is its energy density. A single uranium fuel pellet can produce as much energy as a ton of coal, making nuclear power a highly efficient way to generate electricity. Nuclear power plants play a crucial role in meeting global energy demands. They provide a reliable source of baseload power, meaning they can operate continuously for extended periods, unlike some renewable energy sources that depend on weather conditions. However, nuclear power also comes with challenges, including the safe disposal of radioactive waste and the risk of accidents, as seen in Chernobyl and Fukushima. Despite these challenges, nuclear power remains an important part of the global energy mix. It's a testament to our ability to harness the power of the atom for peaceful purposes, providing clean energy to millions around the world. You know, we often take electricity for granted, but have you ever stopped to think about how that power gets from the power plant to your home? Well, it's all thanks to high-voltage transformers, the unsung heroes of the power grid. These massive electrical devices are absolutely essential for long-distance electricity transmission. They step up the voltage of electricity generated at power plants to hundreds of thousands, or even millions of volts. And why is this so important, you ask? Transmitting electricity at higher voltages reduces energy loss during transmission. Think of it like a garden hose. The higher the water pressure, the farther the water can travel with less resistance. Once the electricity reaches its destination, typically a substation near your neighborhood, other transformers step down the voltage to a safer level for distribution to homes and businesses. High-voltage transformers are, honestly, marvels of engineering. They're designed to handle massive amounts of power and withstand extreme weather conditions. They're the silent guardians of the power grid, ensuring a reliable flow of electricity to keep our lights on and our devices running. So, the next time you plug in your phone or turn on a light, just take a moment to remember the crucial role that high-voltage transformers play in making it all possible. Ever wondered how steel, one of the most essential materials in construction and manufacturing, is made? Well, a lot of it starts with electric arc furnaces, massive cauldrons that use electricity to melt scrap metal. These furnaces work by creating an electric arc between electrodes and the metal scrap. The temperatures inside these furnaces can reach over 3,000 degrees Fahrenheit, hot enough to melt even the toughest metals. Electric arc furnaces are incredibly energy intensive, drawing huge amounts of power from the grid to create these extreme temperatures. But they're also highly efficient, allowing steelmakers to recycle scrap metal and reduce their reliance on traditional blast furnaces, which have a larger environmental footprint. The steel produced in electric arc furnaces is used in a wide range of applications, from building bridges and skyscrapers to manufacturing cars and appliances. So next time you see a towering skyscraper or drive a car, remember the power of electric arc furnaces, transforming scrap metal into the building blocks of our modern world. From the fiery depths of steelmaking, we now set sail on the open ocean to explore the floating cities of power aircraft carriers. These massive warships are essentially self-contained cities, complete with their own power plants, water treatment facilities, and even air traffic control towers. To power all of this, aircraft carriers rely on onboard nuclear reactors or gas turbine engines. These power plants generate enough electricity to power a small city, providing the energy needed to launch aircraft, operate weapon systems, and keep the ship's crew of thousands comfortable. But it's not just about raw power. Aircraft carriers are also equipped with sophisticated electrical distribution systems that ensure a reliable flow of power to all areas of the ship, even during combat operations. The sheer scale of these electrical systems is mind-boggling. We're talking about miles of electrical cables, thousands of electrical components, and a team of highly skilled technicians working around the clock to keep everything running smoothly. Aircraft carriers are a testament to human ingenuity and our ability to project power across the globe. They're floating fortresses of technology, showcasing the critical role that electricity plays in modern naval warfare. Finally, let's bring it back down to earth and talk about a different kind of power, the Tesla Model S Plaid. This all-electric sedan has taken the automotive world by storm, shattering performance records and redefining what an electric car can be. At the heart of the Model S Plaid is its tri-motor electric powertrain, which generates over 1,000 horsepower. That translates to a mind-blowing 0 to 60 miles per hour time of just under 2 seconds, making it one of the quickest production cars ever made. But the Model S Plaid is more than just a straight-line rocket. Its advanced battery technology gives it a range of over 400 miles on a single charge, and its autopilot system offers a glimpse into the future of self-driving cars. The Model S Plaid embodies the future of electric vehicles, powerful, efficient, and packed with cutting-edge technology. It's a testament to the fact that sustainability and performance aren't mutually exclusive. It's a sign of things to come, as electric vehicles continue to push the boundaries of what's possible in the automotive world. And there you have it, the top 10 most powerful electrical devices in the world. From the subatomic realm of particle physics to the vastness of space, these machines represent the pinnacle of human ingenuity and our quest to understand and harness the power of electricity. Which one amazed you the most? Let us know in the comments below. And don't forget to like and subscribe for more tech content. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible. Peace out!